America's coastline ripped apart. Overnight, what's happening? A swarm of small earthquakes has struck southeast Missouri over the last 24 hours, with the strongest measuring a magnitude of 3.0 around 12:30 a.m. These tremors bring to light an unsettling possibility. The most powerful earthquake ever recorded east of the Mississippi River, which occurred over 2 centuries ago, may still be influencing the region. This could redefine our understanding of seismic persistence, challenging traditional notions about the lifespan of aftershocks. For generations, the small brick house has been a spot where people would shelter from the wind while watching the surf during a storm. Bristol, Maine, a fierce storm tore apart one of Maine's most familiar historic buildings. The old Fog Bell House at Pemaquid Point suffered heavy damage when the wall facing the ocean was ripped open. The Bell House, with its white wooden tower, is close to the famous Pemaquid Point Lighthouse and is visited by hundreds of thousands of people every year. For generations, the small brick house has been a spot where people would shelter from the wind while watching the surf during a storm. As far as we know, no one was there to see it happen, but the front wall and an end wall caved in, with the huge bell ending up inside with a pile of bricks and broken wood. It's not clear whether waves hit that high or if it was primarily caused by the wind. Before dawn, as the storm was raging, the automated weather station near the lighthouse reported wind at 54 miles per hour, with gusts up to 68 miles per hour. The New Madrid earthquake sequence of 1811 to 1812 was a geological phenomenon of staggering proportions. It began in December 1811 with a violent shock in northeastern Arkansas, an area sparsely populated at the time. Yet its impact was astonishingly far-reaching. Tremors were felt nearly 1,000 miles away in Washington, D.C., where White House chandeliers swayed, and as far as Boston, where church bells rang. The Mississippi River momentarily flowed backward, carving new waterfalls into the terrain. The town of New Madrid, Missouri, was obliterated, and the shaking continued intermittently until late January 1812, culminating in another massive quake near the confluence of the Ohio and Mississippi rivers. Geologists attribute these events to the New Madrid Fault, which likely transferred stress to the nearby Reelfoot Fault. 2 weeks after the initial quake, another powerful tremor struck, creating Reelfoot Lake in Tennessee. The upheaval was so severe that the Mississippi River became a chaotic scene of uprooted trees and damaged steamboats. Even cities like St. Louis, 160 miles away, suffered structural damage, and tremors were felt as far north as Montreal, Canada, over 1,000 miles from the epicenter. Today, the New Madrid seismic zone remains active, experiencing around 200 small earthquakes annually. Some researchers believe up to 30% of these tremors could still be aftershocks from the early 19th century events. Using advanced statistical methods, geologists suggest that as much as 65% of recent quakes in the area may be linked to the historic New Madrid sequence. This phenomenon isn't unique to Missouri. For instance, a massive quake in Charleston, South Carolina in the late 19th century may account for up to 72% of seismic activity in that region since then. The underlying geology of the New Madrid region offers further clues. The area sits atop ancient rifts in the North American plate, remnants of a supercontinent called Rodinia that began breaking apart 750 million years ago. These rifts left weak zones in the crust, explaining the persistent seismic activity. The debate over long-term aftershocks highlights the dynamic and unpredictable nature of Earth's geological forces. While earthquakes typically last only seconds to minutes, a rare type of seismic event defies this norm. Scientists point to a slow slip event in Sumatra that spanned 32 years, eventually triggering a devastating quake and tsunami. If evidence confirms that aftershocks from the New Madrid earthquake sequence are still occurring, it could reshape our understanding of seismic timelines. Beyond earthquakes, natural disasters remind us of Earth's restless nature. From continuously erupting volcanoes like Mount Yasur in Vanuatu to ancient coal seam fires such as Australia's Burning Mountain, the planet's geological forces are both awe-inspiring and devastating. Burning Mountain, smoldering for at least 6,000 years, exemplifies Earth's hidden power. This underground coal fire heats the ground like a massive oven, causing cracks and collapses that invite more oxygen to fuel its relentless advance. Scientists believe it could burn for centuries or even millennia if left undisturbed. The New Madrid seismic activity is part of a broader narrative of Earth's dynamic history. Over 200 million years ago, a series of massive volcanic eruptions in modern-day British Columbia and Alaska altered the climate, paving the way for the age of dinosaurs. Similarly, the eruption of Mount Pinatubo in 1991 demonstrated the global impact of volcanic activity, temporarily cooling the planet. The caboose in a long train of storms is in sight along the Pacific coast from Washington to Northern California. But AccuWeather meteorologists warn that the last rounds of rain can trigger flash flooding and mudslides, and lowering snow levels over the Cascades and Sierra Nevada can stall travel into Sunday night. Big waves will continue to pound the California coastline. Rain of varying intensity from the final storm in the series will pour down and continue into Sunday from western Oregon to northern California and western Washington. Rain totaling 4 to 8 inches will occur mainly from southwest Oregon to northwestern California. The AccuWeather local storm max rainfall of 18 inches can be approached over the west-facing slopes of the Coast Ranges, Siskiyous, and Oregon Cascades. Rainfall of this magnitude, on top of saturated ground from prior storms, is more than enough to lead to flash flooding of urban areas and small streams, mudslides, and road washouts. Enough rain will fall to make roads slick in at times in Seattle, San Francisco, and Portland, Oregon, as well as Sacramento, California, Eugene, Oregon, and Astoria, Washington. Winds will become strong enough from northwestern California to southwestern Washington to tip trees over in the saturated soil and cause large tree limbs to break in some cases. Both can trigger sporadic power outages. Winds from the west will help to drive large swells toward the California coastline into Monday. The big breakers will create dangerous surf and strong rip currents for Southern California beaches. The storm and its rain and mountain snow will avoid nearly all of Southern California and Southern Nevada. Soil conditions will remain dry as a result. As the Caboose storm moves inland, high pressure will build over the Great Basin early this week. The setup for Southern California is likely to trigger a Santa Ana with northeast winds from Tuesday to Wednesday. The storm break will allow cleanup operations to commence and provide decent travel conditions in the region. The next storm will likely bring low-elevation rain and mountain snow by New Year's Day to areas as far south as the northern tier of California. Even Antarctica, often envisioned as a frozen, desolate expanse, hides over 130 volcanoes beneath its West Antarctic ice sheet. Most remain dormant, but active volcanoes like Mount Erebus, with its persistent lava lake, highlight the region's fiery secrets. The interplay between glacial periods and volcanic activity underscores the complex relationship between Earth's climate and geological forces. Volcanic activity also dominates regions like Iceland, where over 130 volcanoes have shaped the landscape. The 2010 eruption of Eyjafjallajökull disrupted air travel across Europe, highlighting the far-reaching effects of such events. Iceland's unique geography, straddling the boundary between the North American and Eurasian tectonic plates, makes it a hotspot for volcanic activity. These forces have formed a land rich in basaltic lava, leaving only a quarter of the island habitable. Meanwhile, the Pacific's Ring of Fire, home to 75% of the planet's active volcanoes, underscores the global nature of seismic and volcanic activity. In Hawaii, Mauna Loa, the world's largest volcano, poses a different kind of threat. Its broad, low-profile shape and fluid lava flows contrast with the explosive nature of stratovolcanoes, but recent seismic activity raises concerns about a potential eruption. The New Madrid seismic zone and its counterparts around the globe remind us of the Earth's relentless dynamism. From massive earthquakes to slow-burning fires and erupting volcanoes, these forces shape our planet's past, present, and future. The question remains, how can humanity coexist with such powerful natural phenomena? Ongoing research, monitoring, and preparedness are key to navigating this ever-changing landscape.